All right.
That's
2, 4, 5.
okay. Very sorry, we are having some system glitch, but don't worry, your jam must go down. You must key the jam. Now, from where we stopped, remember we said the SI unit for physical, in numbers. And because there are 7 in numbers, please pause this video. Pause it for me. Get me my mic. The mic is in my chest. Okay, look at my mic here. That's great. I was looking for it because I was just holding the mic. Sorry. Now the SI unit for physical measurement is what? Remember your fundamental quantities are delta, melta, fundamental quantities. This is your mass. Remember, don't forget. Your mass is measured in what? Kilogram. This is your electric current, okay? Please share the link with your friends. I know we're having some system English, but the network will soon be clear, okay? Please just share with your friends. Let them come online to enjoy this video with you, okay? Now, if you have electric current, the unit is ampere. This is the SI unit, ampere. This is your length, and the unit of length is of substance. Amount of substance. Don't forget the unit is what? Mole. Then this is your luminous intensity. Your luminous intensity is measured in candela. So these are your 7 fundamental quantities, class. This SI unit for physical measurement is what? The answer is what? Do you have pounds in this place? No. Do you have feet? No. A cannot be the answer. Now, check the other option. Do you have grams in this place? No. Your unit of mass is what? Kilogram, not gram. So cancel it out. Option It is the unit for angular displacement. List what graduated. Centimeter, then D 2.0 centimeter. B. Now let's take one more question. A fundamental unit. Now, why is it always hooking?
No, it's not hooking. This one is not hooking now. They can't hear you.
Okay, we apologize for the short break. Okay, now which of these is a fundamental unit? Which of these is a fundamental unit? Okay, now remember your Newton is the unit of force. Okay, now your watts is the unit for power. Joule is the unit of work or energy. And finally, your second is the unit of time. Remember, all of these are derived quantity apart from time. So, when they said that which of these is a fundamental unit, the answer to the question is second. Remember that second is a fundamental unit. Please make sure you take your pen and your notes. Jot every important thing that we are doing in this lesson. Okay, we are going to the next chapter of physics. which is your dimension analysis. Let's take chapter number 2. Chapter number 2. Chapter 2. Okay. Dimension analysis. Dimension analysis. Okay. Now, remember that if we want to begin with dimension, it will be important for us to bring out our dimension for fundamental quantities. Your fundamental quantities, which are, remember I gave you an acronym. The acronym will always guide you. Meta. I repeat again. This is your mass, okay? Mass is measured in kilogram and the dimension is capital letter M. Electric current Electric current is measured in ampere and the dimension is capital letter I. Some textbook or some other sources uses A. Okay. L is measured in meters and the dimension is, that's length is measured in meters, dimension is equals to L. For any quantity measured in meter, they have L as their dimension. So if it is breadth, it is L. If it is height, it is L. If it is distance, it is L. If it is displacement, because they are all measured in meter, the dimension will be what? L. Are you getting it? So now let's continue. Your mass, length. Let's talk about time. Your time is measured in what? In seconds. The dimension is T. Now, if we have this, remember the other T means what? Temperature. And temperature has a dimension which is Kelvin. Kelvin is measured in Kelvin, so dimension is K. So for mass, you have M. For current, you have I or A. For length, you have L. For time, you have T. For you have K. Okay. Then amount of substance. Amount of substance is N. Okay. Luminous intensity that is measured in candela is what? C, or we can use C subscript D. Let's just leave it as C. Now, if I have this as the dimension for my fundamental quantity, and I am to look for the dimension of number 1, work. Remember that work is the same as your energy and the same with your what? Moment. The same with your couple or talk. They are all the same. Why did I say they are the same? Although your work and energy are measured in joules, but your moment and couple as well as torque are measured in Newton meter. But the general formula for all of these quantities is that they are equals to force times distance. If you want to get the dimension for work, you must know their word, their formula. If you know the formula, you can get the word, the dimension. Are we together? Yes, if you know the formula, you can get the word dimension. Now, okay, now I think that we are going to do this. If I have the formula for work, energy, moment, and couple, and I want to get the dimension for all of these quantities, what I will simply do is this. Remember that your force is equals to mass times what? Acceleration. Then your distance remains distance. Let us now put their unit. Mass is what? Kilogram. Acceleration is meter per second square, while your distance is also what? Meter. So if you multiply together, you have kilogram meter square per second square. Wow, so interesting, because meter times meter will give us meter square. So let's quickly put their dimension now. What is the dimension for kilogram? Remember that kilogram is mass and is M, so you have M. Okay, what's the dimension for meter? Meter is length and is L, so you have L square. What's the dimension for seconds? Seconds is T, so you have T raised to the power of minus what? 2. This is the dimension for not only work, but energy, moment, couple, and torque. Because they have a general formula, which is force times distance, this is their dimension. Are we together, class? Now, please share this link with your friends. Now, let's go to number 2. If I'm looking for dimension of impulse, please, impulse and momentum goes together because they have a general formula, so they share the same unit. The general formula for impulse and momentum, although your impulse is force times time and your momentum is mass times velocity, but by the time you break this force times time, you will see that you have mass times velocity. So the formula for impulse and momentum, they are what now? They are the same. So whenever you want to get the dimension for impulse, you can use the dimension for momentum to get it, and you can as well also switch it. You either get the dimension for impulse or the dimension for momentum. They are both words the same. Now, what do we simply do? Remember, if I'm looking for momentum or impulse, please take note of this. Let us use the formula for momentum, which is mass times velocity. Mass is what? Kilogram. Velocity is meter per second. Remember that anytime you see kilogram, it means capital letter M. Whenever you see meter, it means what? L. Whenever you see seconds, it means what? T. Whenever you see Kelvin, it means what? K. Whenever you see ampere, ampere means what? I. So get this down. Please. Very important. These are fundamental units and these are the fundamental dimension. Now, if I know that momentum and impulse is mass times velocity, then mass is kilogram, velocity is meter per second. I can simply say kilogram is M, meter is L, seconds is T. So you have T raised to the power of -1. Are we together? So if they ask you in your JAM, which of these units has the same dimension as impulse, the answer is momentum. Or if they say which of these units has the same dimension as momentum, the answer is what? Is impulse. So take note, impulse and momentum, they have the same units. Your work, energy, moment, couple, and torque, they have the same what? Units. Okay, they are referred to as equivalent quantities. I have another one for you. Now, number 3, if I'm talking about pressure, class, pressure, remember that pressure is the same thing as stress. I'm using the word stress because we have volume stress, don't forget, we have shear stress, and we have tensile stress. They are force over area. So pressure and stress, as well as your moduli of elasticity, pressure, stress, and moduli of elasticity, they have the same general formula, and the general formula is that they are all equals to force over area. Please write it down. Okay, they are all equals to force over area. I know that moduli is tensile stress over tensile strain. Remember that your tensile strain is extension over original length, so you no get any units. If you divide meter by meter, is unitless. So we are working with force over area as the unit for Young modulus, bulk modulus, shear modulus. Those 3 modulus are called the moduli of elasticity, and it's the same with your pressure and your stress. So let's work with the general formula for all of them that says it is force over what? Area. And if it is force over area, remember, force is mass times acceleration, but your area is length times breadth. Let's put their units, please. Remember that mass is what? Kilogram. Acceleration is meter per second square. And then your length is meter, breadth is also meter. So this meter here cancel this meter. We are left with kilogram per second square all over meter. Don't forget the power of this meter is 1. So if you take this 1 up, you have kilogram, meter raised to power -1, seconds raised to power -2. So kilogram is M. Don't forget kilogram M. Meter is L -1. T raised to the power of -2. This is the dimension for what? Momentum and impulse. Don't forget, we are going to be looking at the very constructing variable that can easily come out in your JAM. That's why it is called the revelation hour. Make sure you write every important note that is given to you in this video lesson. And please do not forget to like our videos. Okay, let's take just two other quantities that we are suspecting to see in your JAM exam 2024. Just two, please. Two. Wow, I just remember. And now, what is the dimension for the universal gravitational constant? What is the dimension for the universal gravitational constant? Please help us to share our link. Please help us. Okay. Now, tell us what you feel about this, our video lesson in the comment section. And if you are enjoying our lesson, if you want to pass your JAM, you want God to help you in your JAM, don't forget to like this video. Thank you. Now, what is the dimension for universal gravitational constant? Now, the question is simple. What is the formula for universal gravitational constant? If you know the formula, then you can get the dimension. Is that clear? What is the formula? Go back to Newton's law of universal gravitation. The Newton's law of universal gravitation reveals to us that the force of attraction between two masses is directly proportional to the product of their masses. That's Newton's law. Newton's law of universal gravitation. Newton's law of universal gravitation states that the force of attraction is what? Equals to gm1 m2 over r squared. Please, I want you to know, I know that many of you want to write some of the things I'm saying, but I want you to also know that if it is important, I'm going to put it on the board. So what you have to do is to make sure that anything you see on the board, write it down in your notes. Okay? Now, this is our universal gravitational constant. We are going to make this guy subject formula so that we can determine the dimension. Okay? So if you cross multiply this way, you have F arrow square equals to what we left here, GM1 M2. Remember looking for G, so we divide both sides by M1 times M2. You do the same here, M1 M2. So this one, what this was remaining, your universal gravitational constant is equals to F arrow square over M1 times what? M2. Wow. Now let us begin to break it down. Force is mass times acceleration. Radius is also radius. And this is mass times another mass. Wow. Now I can use this mass to cancel this mass. So I'll be left with A arrow square equal all over. This is now remaining one mass. So let us just put it like that. Mass. Now let us begin to put their units. Remember that acceleration is meter per second square. And radius is meter. So you have meter square. Why this mass is kilogram, so you have kilogram here. Don't forget that the power of this kilogram is 1. And if the power of the kilogram is 1, what do we simply do? You take it this way. So you have kilogram raised to the power of minus 1 times what? Remember, this one is coming here. This kilogram raised to the power 1 is coming here. That's how we have it this way. Meter times meter square. Are you getting it now? M times m square. Seconds raised to the power of minus 2. Again, if you know your Newton's law of universal gravitation, write it. Make G subject formula. You have this. Force is mass times acceleration, then arrow square. Mass and mass is here. So I'm using this mass to cancel this mass. So I'm having A arrow square over M. That's what is here. No need to write M1. The reason for having M1 and M2 is because there are two different masses there. Okay, so you can just put M. Now, if I have M is mass, don't forget. Now, acceleration is meter per second square. Radius is meter, so you have meter square. Mass is kilogram, so you have kilogram. If this kilogram raised to 0.1 goes up, it will take a negative sign. This is M times N square to give you M cube. And this is S raised to the power of minus 2. So that's what you have. Wow. So our dimension is now what? M raised to power minus 1 meter Meter is length, so L raised to the power of 3. And seconds, it will be what? T raised to the power of minus 2. Take note of this. This is the dimension for the universal gravitational constant. If I compare this to an equation where I have m raised to power s, L raised to the power of y, T raised to the power of z, I can say that s is equals to minus 1, y is equals to 3, and z is equals to minus 2. Please write it down. Okay, I'm going to take just one more, which is our potential difference. Okay. Now, one more. What is the dimension for potential difference? What is the dimension for potential difference? PD. What is the dimension for potential difference? Potential difference is the same as voltage. Please write it down. And now, if they are the same, potential difference, which is PD, voltage and EMF, they are the same. Don't forget we are in chapter 2 of physics right now. Now, what is the dimension for voltage, EMF, potential difference? You have a general formula. Because they are all measured in volts, you can say that volts is the work done in taking a unit charge. Take note of that. Potential difference is the work done in taking a unit charge. Okay? Or the force required to drive the current around the circuit. Work done over charge is your voltage, is your potential difference, and it happens to be your EMF. So, what is the formula for work? Work is force times distance. Okay, let me use D to represent distance. While your charge is current times time. Now, if I break down force, I have force is mass times acceleration, then times distance, all over current times what? Time. Let us begin to put our what? Our units. Mass is kilogram, don't forget. Acceleration is meter per second square. Distance is what? Meter. Then remember, I means what? Current. And current is measured in what? Ampere. Time is measured in what? Seconds. So let's combine together. This is kilogram. Meter times meter will give us what? Meter square. Okay. Here is s raised to power minus 2. We have combined the numerator all over a what? X. Now, if I decide to bring this is a raised to power 1, s raised to power 1. Okay. You can ask your question in the comment section. If you have any question to ask, send it to the comment section. If my speed is too fast, please send it to the comment section. If you have any problem or question you want to ask as regarding the topics we have considered or the topics you want us to treat in this video, send it to the comment section. And now, let's continue. If you have your kilogram, this is your meter square. Now, this is your seconds raised to power minus 2. Remember, the power here is 1. This is seconds and this is seconds. You pick only one of them. You combine the power. So, because the laws of indices says that you minus, and this is a raised to the power of what? Minus 1. Remember that this a raised to power 1 to become minus 1. S raised to power 1 will become minus 1. But I'm not writing the S 2 times because you already have X here. So you pick just one of the X. Okay, so that's good. Then you have kilogram meter square per seconds cube a raised to power minus 1. What is the dimension for kilogram? Capital letter M. Meter is L square. Then your seconds is T raised to power minus 3. Ampere, you can leave it as A or you can use I raised to power minus 1. This is the dimension for what? Potential difference, voltage, and what? EMF. Is that clear? Now take this classwork and do it for yourself. Give me the dimension for power. Do that very fast. Dimension for power, dimension for force. Do that very fast. I'm giving you 30 seconds for power and 30 seconds for force. Okay, do that very fast. No, you can't pause this. No, sorry. Have they come back? Okay, now your 1 minute is over. Let's do it together. Now you have power. Please share this video with your friend. Share the links with your friend. Okay, share it with your friend. Thank you. Okay, their answers. Wow, that's great. I'm seeing your answers already. Wow, that's great. Okay, take. Thanks. Some of you attempted and you got it correctly. That's good. Kudos to you. Much love from me to you. Okay. Now your power. Remember, your power is equals to work over time. Power is energy over time. Power is force times velocity. Power is mgh over time. Power is 1 over 2 mv square over time. These are the formula of your power. You can use any one of them to get your dimension. Remember, if you have a number like 1 over 2, you remove it if you want to use to get dimension. Okay. Now let us get our power from the first formula. You can use any of them. If you're using this one, remember, or we can use this either. Power is equal, let's work with this. Mass times gravity times height over time. You can work with this. What is mass? Mass is measured. I like, some of you are very interesting. Thanks for attending to this question. You are going to pass your jam. Okay. Now this is acceleration. You have meter per second square. This is height. So you have meter. This is time. So you have seconds. Wow. That's great. Let's combine together. Remember, here remains your kilogram. Meter will give us meter square x raised to the power of what? Minus 2 over x raised to the power of 1. So what do? Very easy. You have kilogram. This is your meter square. Remember, you are combining these two. I've told you before. When you are combining, you have x raised to the power of, this is minus 2, and then this is 1. So you bring another 1. So you have kilogram meter square x raised to the power of minus 3. Kilogram is capital letter M. This is L square, and this is T raised to the power of minus 3. So you can mark yourself. Mark yourself. Go back again. Mass is kilogram. Acceleration is meter per second square. Height is meter. Time is seconds. So if you combine meter, you have meter square per second square, and this is seconds. So if you combine these two, you have minus 2 minus 1. Wow, this is the dimension for power. As for force, the formula for force is mass times acceleration. Remember, mass is what? Kilogram. Acceleration, meter per second square. Kilogram is capital letter M. Meter is L. Seconds is T raised to the power of minus 1. Dimension forward power. We are done with this chapter called dimension. We are going over to chapter 3, which is the scalar and vector quantities. What is a scalar quantity? Chapter 3 now. Chapter 3. Okay. If you have my physics textbook, you can be guided with this physics textbook. We are in chapter 3, which is what? Scalars and vectors. Wow. Scalar quantity are those quantity that has only magnitude but without direction. This one, they don't get direction. They are made up of magnitude only. Magnitude only. This one, they have both magnitude and direction. Okay? Now, if I do scalars versus vector, I will tell you if I draw a table here for scalar and I put a table here for vector. Now, I can tell you, number one, all fundamental quantities, are scalars. All fundamental quantities are scalars except luminous intensity. All fundamental quantities are scalars except luminous intensity. That's one. Now, for derived quantities, some of them are scalars, some are vectors. Okay. Now that's number one. If I take number two to tell you mass is a scalar quantity, a constructing variable of mass here is your weight. Weight is a vector, and even your force is also a vector. If I write number three, if I write speed here, class, speed, remember that speed is v and speed is meter per seconds. Your velocity is a vector, is also v, and it is meter per seconds too. Now let me add to this. I can add acceleration here. I can add momentum here. I can add impulse here. Are we together? Take note. Okay. Now let's continue in the other side. This is your scalar and this is your vector. Ladies and gentlemen and ladies, Aboki and Abokres, if I say that there is speed here, there will be what? Yeah, velocity. Okay, we've done that. If I say this is distance or height or altitude, then don't forget all of these are measured in words, meters. All these guys, distance, height, altitude, they are what? Meters. But they be scalar, shebi you know. But write this guy here, displacement. What is displacement? Displacement is the distance that is measured in a specific direction. Now, vector quantity. Now, if I write like this, temperature na scalar quantity. Gradient. Temperature, some of you have not heard of this before. Temperature gradient is a vector. Gradient is change in temperature over length. So the unit na Kelvin per meter. Take note of that. Temperature na scalar, but temperature gradient is a what? A vector quantity. Now, class, take note of this important fact. If I write mechanical advantage, na scalar or na vector? Scalar. If I write velocity ratio, scalar or vector? Scalar. If I write efficiency, scalar or vector? Scalar. If I write reactance, if I write impedance, if I write resistance, please be writing these things down. If I write conductance, and if I write capacitance, what are they? They are all scalar quantity. Please write them down. But if I go the other way around and I write fields, please take note. All fields are vector quantity. There's what we call magnetic induction. Magnetic induction is a vector quantity. Remember, field could be gravitational field, electric field, or magnetic field. They are all vector. Magnetic induction, magnetic flux. Magnetic flux density is also a word, a vector quantity. So there are many vector quantity as well as scalar quantity. Okay, let us continue class with some other quantities. I have just a few to give you. If we have scalars here, have vectors here. Now let's continue class. If your density is scalar, your flux density will be what? Vector. Please take note of that. Density is scalar, flux density is what? Vector. Okay, what other unit do we have that are scalars and vector? Remember, I've given you acceleration, velocity, momentum, impulse. Wonderful. I just remember, if you have work and energy here, if work and energy are scalar, then moments, wow, moment, couple, and torque, they are all what? Vector quantity. Work energy is a scalar. Moment, couple, and torque are what? Vector quantity. Now, why did I bring these two variables to construct them? Work and energy is force times distance. Moment, couple, and torque is also force times distance. Some people used to say it is force times displacement to specify the difference between them and the constructing word scalar. Please take note of this. Now, if I write for you pressure, what is the formula for pressure? Pressure has two basic formula. It is force over area or density times gravity times depth. Okay, now if we work with force times area, we'll find out that stress and moduli, wow, moduli of elasticity are what? They are vector. Modular of elasticity are vector. When I say modular, what am I talking about? I'm talking about Young's modulus. I think I have to clean the board to create a space for myself. Now, let me clean this side of the board. I almost have written this down. Now, ladies and gentlemen, we will talk about moduli. We have the Young's modulus. Young modulus. That one now, tensile stress over tensile strain. That's Young modulus. And it's a vector quantity. Now, if I talk about bulk modulus, is equals to volume stress over volume strain. Yes, so this is your bulk modulus. This one came out in your JAM mock exam. I told you it's still going to come out in your JAM exam. So please note this down. Very important. Again, the last moduli is called your shear modulus. Shear modulus. This one is JAM mock. JAM mock 2024. Please help us to share this link to your friends to join us in this video lesson. And God will bless you and increase your JAM score as you do that. Okay, now shear modulus is equals to shear stress over shear strain. Please take note of this. We will expatiate more of this in elasticity of solid material. So take note that moduli of elasticity are vector quantity. I have one more to go. Please do not forget that if I get flux linkage, I beg you, write them down. If I get flux linkage, it is a word, a scalar, but flux is a word, a vector quantity. Write them down, I beg. I beg you in the name of your JAM score and the name of your unborn children. Please write it down. Now let us go to resolution of vectors. Please screenshot as you are writing. Screenshot it. Let us go to resultant vector. Resultant vectors. Very easy class. Now, what is a resultant vector? A direction as two or more vectors taken together. I repeat again. It is that single vector which will have the same effect in magnitude and direction as two or more vectors taken together. What do I mean? Now, with the cases we are going to consider on the board today, you will see what a resultant vector is. Now, case number 1. If I have two vectors this way and a force of P drags it here, one drags it here called Q. If your P is greater than Q, it means that because this one big pass this, it go this way. Abi now. So your resultant will be what? The bigger one minus the smaller one. Take note of that. I'll give you one illustration. If I have a block of mass and it is pulled by a force of 200 Newton and another force here of 150 Newton pulls it, which direction this object will go, class? Tell me. Now here go. Is it towards the direction of east? Sorry, towards direction of west or towards direction of east? Which side it go? Shaping now here go. Yes, because say this one big pass this one. Abi now? Yes. Now, if you don't do it, what will be your resultant? It will be the bigger one minus the smaller one. Abi now? So you will have 200 Newton minus 150 Newton to give you 50 Newton. Are we together? Now, there's this question that came out in JAMOC. Okay, although I cannot remember the figure correctly, as for this, I think I've saw it before in my previous video. If you haven't watched our JAMOC videos part 1, 2, 3, and 4 in series, please do that. Now, if I have a force of 9 Newton and another force of 3 Newton pulling a mass of 50 grams, they now said find the what? The acceleration of the body, of the weighting of the body. Find the weighting, acceleration. Very easy. Before you go fit find acceleration, you must know the force where they pull the object. Which force they pull the object, class? Make I ask you now. Now 3 Newton force or now 9 Newton force? The force where they push the object, now the resultant, no be the 3, no be the 9. Now the resultant force they pull on. And wetin be the resultant force? Very easy. Your resultant force is equals to 9 minus 3. Shebi I fit tell una say if the force they go in opposite, yes, you go minus am. So 9 minus 3 go give us 6 weighting Newton. If this one 9 be the force, this is the extra 6 wey add join the 3 wey 9 make the mass dey move, no be 9, no be 3. So the resultant force is 6. And if the resultant force is 6, what do we do? Very easy. Remember that force is mass times acceleration. Abi now? Yes. And if it is mass times acceleration, what is your force? We don already get 6. You write am down. Wetin be your mass? 15. Acceleration is what? A. Wow, that's very good. And if that happens, you divide both sides by 15, abi now, so that make you forget your A. So if you say 6 is equals to 15A, you go this side by 15, go this side by 15, abi now. So if 15 optimize 15, you have A. 6 over 15. Let's quickly do this. If I divide here by 3, I go get 2. If I divide here by 3, I'll get weighting 5. So 2 over 5 will give us 0.4 meter per second square. Please take note of that. Take note of that. So for case 2, abeg mo rush am fast. Now case 2, if the two force they act in the same direction, P and weighting Q, how do I get the resultant? You go plus them together, P plus Q. Take note of that. Take note of this. So if they go in opposite direction, you go minus them. But if they go in the same direction, you go add them together. That's case number 2. Now let us go to case number 3. Now in case number 3, we have two perpendicular forces. Now, two forces are said to be perpendicular if they meet at right angle. Abi now? Now, if I get one force like this and that force like this, should be these two forces they perpendicular? Yes, because the two forces meet at 90 degrees. The force way they here, they call them Fy. The force way there, they call them Fs. Abi now? Yes. So very simple. How do I get resultant? The resultant is gotten from here like this arrow. So this angle now can become the direction where the resultant make with the horizontal line. This fy, if you transfer am come here, I'll put my fy here. Wow. Remember, this guy is the s axis. This guy is the y axis. Don't forget we are talking about scalars and vectors. So we are in case number 3. Now, if the two vectors are perpendicular, how do they get resultant? You go use Pythagoras theorem. Pythagoras theorem say arrow sequoia is equals to fs sequoia plus fy sequoia. Now Pythagoras theorem be this. Pythagoras theorem. Abi now, please let me remind you again, like our videos. If you like them, your jam score will increase. If you share this video, your jam score go increase. I'm telling you, just believe and do it. Now, the resultant will give us this. There's wetin we dey call horizontal component class. Some of una don first teach una for class before. I tell una say anytime wey una dey use horizontal component, shebi you must use cos theta. Yes, you must use cos theta. Whenever you are looking for resultant component, use cos theta. Why? Because I don first explain before say along this side na the s axis, and if you resolve am come here, e go be cos theta. And because of that, what do we do? Our fs now, if you dey find this force wey dey here, your fs now, e go be arrow cos theta. Oya, write am down fast fast. Fs is arrow cos theta. Abi now make we talk about the vertical. We know say we no get too much time for this video, so na why I dey do am like this. So just dey write am down as I dey write am. If you dey find your vertical component, you go say fy. Remember say vertical component na the y-axis, abi now. So you go get wetin? Arrow sin theta. Oya, write am down fast fast. Now, that one na for which case class? That is for case wetin na 3. Now, we come go to the call case 4. Case 4, or should I give you a question? Now, as my spirit is leading me, let's do this question. Let's take this question. Two forces, 12 are acting at right angles to each other. Determine the what? Resultant of the two forces. This one a bonus now. Of the forces. Remember, I tell una say if they dey right angle to each other, shebi you know say right angle na the same thing with perpendicular. Abi now? Yes. If they dey right angle, you no need to draw am, abeg. Use wetin we dey call Pythagoras wetin theorem. Abi now? As I dey teach una now, dey write am. Now, Pythagoras theorem say if you dey find resultant, you go take the square of the x plus the square of the y. That's what you need to do. Now, if we say this guy na x and this guy na y, put am here, you get 12 square plus wetin na 5 square. Abi now? Good. So you get 144 plus 25. That will give us 169. So arrow will give us the square root of 169. The answer na wetin na 13 Newton. If you fail this thing for jam, now slap, I go use cover your face. Oh yeah, we'll take another question. Now, watch this. Watch this class. This one is very, very common. A rope whose tension is what? 100 Newton is used to drag a load along the what? Sorry, used to drag a load on the floor. If the is inclined to an angle of 30 degrees, determine one, horizontal components. 2 vertical component. Now I go do only horizontal component. Now una go do vertical component by una self, and I go give una as classwork. If you no get am, I go come your house, come conk you for head. Oh yeah, let's do it now. I'm going to solve just this one. A rope whose tension, remember I say the tension wey dey the rope na the resultant force o. Because if I draw the diagram now, see am. Let's say for instance this one is a yarn and you tie rope with yarn. Watch this abeg. If this thing you tie rope for the yarn, you come dey drag the yarn. If the tension here is shebi this one, the rope make an angle of 30°. Abi now, no be wetin I tell una say this one is called the wetin, the resultant. So if you dey find the fy, you go use the sin theta. If you dey find the fs, you go use the cos theta. Now I go find only the horizontal component for una. Una go find this one now. As you find am, send the answer give me for the comment section. Make I know whether you dey follow. But abeg, make sure say you dey share this link with your friends. Now, I dey find the horizontal component. For horizontal component, I go use cos. So Fs go give us arrow cos theta. Abi now? Yes. Wetin be arrow? 100. So you have 100 times cos 30. Abi now? Yes. 100. Wetin be cos 30? Cos 30 na root 3/2. Yes, yes, yes. Remember that magic table wey I give una for class? For those of you that have not watched it before, I have a video where I made a magic table for trigonometric values. The magic table is very easy. Just draw square root like this for your jam hall. Draw for the paper where they will give you a soft jam. As you draw the square root, divide the square root by 2 like this. Then put all your special angles. The first one na 0. The second one na 30. The third one na 45. The fourth one na 60, and the last guy na wetin, 90. As the square root dey like this now, cut am into 2. One na for sin theta, while the other one na for wetin, na cos theta. Yes. If you wan know about cos theta, sin theta, start from 0. 0, 1, 2, 3, 4. While cos theta start from 4. 4, 3, 2, 1, 0. Abi na? Yes. Oya see am. Don't be distracted, okay? Now, watch this. If you have 1 here and you have 0 yes, how do I find sine? And this cos 30, what they talk about? If you find cos 30, see am. Cos 30°, just run go where cos, they find 30, see am. 390 under 30, see am. This one now na root 3. So you go get root 3/2. Now, so I take get this one. You dey see am now? So I cannot use this 2 to optimize this 100. Yes. If 2 optimize 100, wetin we go get? 50. So you have 50 times root 3, and that will give us 50 root 3 Newton. Now I go give una just 1 minute 30 seconds to take optimize question 2. Oh yeah, do am fast. I'll be back with you in the next 1 minute 30 seconds. Do that fast.
The problem where we get another light. Just check the comments. Wow, we have the answer. Just come again. All the answers.
I've told I will use sine theta. So if I'm looking for Fy, it will be Fy equals to arrow sine theta. I'm telling you. Wetin what do you have? 100 times sine 30. Go under 30, you see am 1. Square root of 1 na 1 over these 2. So 1 over 2. 1 over 2. You call am 0.5. So can these two optimize 100? Yes. So you'll get wetin? 50 Newton. Clap for yourself. Those of you that got it. Let us proceed to case number. I think we are in case number 4, 5 now. Okay, we are in case number 4. In case number 4, please, for two non-perpendicular vectors, okay, in triangle, hello, let's quickly connect it. No. Hello. That's on. Okay. Okay. Hello. We apologize for the system glitch. Now I hope you can hear me better now. Now, when you are looking for resultants, if you are looking for the resultants for two non-perpendicular vectors, we use the cosine rule. Now, the cosine rule is this: arrow square is f1 square plus minus 2f1 f2 cos theta. This is cosine rule. If the vectors are non-perpendicular, as in if na acute angle or na obtuse angle, you must use your cosine rule. Are we together? So what do we simply do now? Wow, very easy. If na direction you define direction, for direction we go use Lamis theorem. Lamis theorem. Lamis theorem is also called sine rule. Is also called sine rule. Sine rule. Okay. Now I'm going to give you one simple question. We'll solve this question now using the parallelogram law of vector, the triangle of forces. Let's quickly take this question. Now, let's take this question. Let's take this question. Non-perpendicular vectors. Let's take this question. Non-perpendicular vectors. Two forces, 8 Newton and 6 Newton, act at an angle of 60 degrees to each other. 60 degrees to each other. The resultant force between them is what? I guess if I solve this question, you will be able to solve other questions because I'm solving this one and I'm giving you another one to solve. But in order for you to be able to solve the other question, you have to be very careful or watch carefully on how I will solve this question. Now, these two vectors are acting at 60 degrees. They are non-perpendicular. This 60 degree is simply an acute angle. Now, if I want to solve, I will better use my parallelogram law vector. First of all, an acute angle is to be this way. And if here happens to be the angle between the forces, the first force is 8 Newton and the second force is 6 Newton. How do I solve this question? Using the parallelogram law of vector. How do I do it? I will create a parallelogram from this simple diagram. How do I do it? Remember, It is called a parallelogram because the opposite side are parallel to each other. So this side is to be parallel to this side, as you can see on the board. And this side is to be parallel to this side also, as you can see on the board. Wow, that's very, very good. Now that we have two forces, remember that parallelogram law of vectors states that if two vectors are represented in magnitude and direction by the adjacent side of the parallelogram, the resultant can also be represented in magnitude and direction by the diagonal of the parallelogram drawn from the point of intersection. And here the resultant dey, which is what? Arrow. And because say na here the resultant dey, you don already divide this angle. So we no dey use the angle wey dey give us take solve the question. We use the angle that sum up with this angle to give us 180. Remember that the angle wey dey here plus the angle wey dey here na 180. And if this one is 60, that means this one will be what? 120 what? Degree. Wow. So if you watch very well, we don't produce triangle. The triangle is going to be like this. Watch. This is the resultant. We draw it this way. This side dey like this. This one dey like this. Now so. See am. Now so. So this is our resultant. Here now. What is this place? They did not give us. We don't know this place. We only know this angle, but we don't know this small angle right there. And the small angle then might be this one. So this one now is 120 degree. It's 120. Why is it 120? Because you use the angle that will sum up the angle to
Complete now.
remove it. I use my voice. It one go inside.
Will it work?
It will work just that. I mean, that's the only way. But I tried this now. Let me not go class. Are you getting it? Watch it. Go and check whether it's coming out. Now, this is the, we are going to use cosine rule. Okay? Now, remember I told you that if the two forces are not perpendicular, if they are not perpendicular, you use your cosine rule. Are we together? Yes. You use your cosine rule with the theory of what? Parallelogram law of what? Vectors. Okay? Wow, that's good. Now, in cosine rule, remember I told you that if you are looking for resultant, see, you go write arrow square, which is resultant square, equals to the first force. If you write this one first or this one first, it no matter. So let's start with this. 8 square plus this one, 6 square, then minus 2 times 8 times 6, then times cos wetin na 120 degree. Yes. So you see am now, e dey very cheap. We have 8 square plus 6 square minus 2. That means if the two forces are 3 and 4, it will be 3 square plus 4 square minus 2 times 3 times 4. So now so dem take dey do am. Here we give us 64. Here we give us 36. Minus 2 times 8 is 16. 16 times 6. We give us 96. So you have 96 times what is cos 60 is 0.5. Cos 60 is synonymous to cos 120 degree. It's just that this time it will be minus 0.5. Why? Because 120 degree is in the second quadrant in mathematics, and in the second quadrant your cos is what? Negative. Wow, that's good. So you have this plus this will give us 100, and please, you must multiply these two together. Don't minus this one from this, you times them together. So minus 96 times minus 0.5, that will give us minus will give us what? Plus. So 96 times 0.5 will give us what? 48, if I'm not mistaken. Okay, now if I have 48, I will add them together. 100 plus 48, 148. Therefore arrow will give us the square root of 148. What will the square root of 148 give us? 148. That will give us 12.16. So you have 12.16 Newton. Wow, that's interesting. This is the resultant force. Now, if you are writing Jan, the highest they will go is that you do the resultant. That's all. Jan will not ask you to find the direction of the resultant force. But in case you want to know the direction, it's very simple. The direction is the angle that is here, theta. So if now theta I define, how I go to do it? Very simple. I go use Lami's theorem. Okay? I will use Lami's theorem to find theta. So how do I simply do it? Very simple. This guy na 6, this guy na 8. Remember, I say here na theta. I don't solve for resultant. My resultant is what? 12.16 Newton. So what do I do? Sine what? 120. That's sine of this angle to the side here. What will be the side? All over 12.16 equals to, what will we define? No be this one. So you do sine theta over the side that faces it, 8. So what is sine 120? Sine 120 is synonymous to sine 60, and that will give us 0.866. Like I told you, you will not see it in your JAM exam. Just believe. You have this over 8, so cross multiply. 8 times 0.866 is 12 point, okay? There's no need of cross multiplying. Let's divide both sides by 12.16 equals to sine theta, okay? 8 times 0.866 divided by 12.16. That will give us 0.5697. 0.5697 equals to sine theta. So theta will give us the sine inverse. That's why I told you will never bring it in your JAM. So, but just know it for knowing sake. What is shift of sine? Shift of sine 0.5697. The answer is 34.973. 34.73 degree. But please, this one should not be your consideration. What you should consider is this. If the two forces are not at right angle, use cosine rule. And if you don't, make sure say the angle they use, not the angle they give you. If they give you 45, you say 180 minus 45. Okay? You get 135. 45 and 135 are the same, except that that one will be minus. That's it. So you will not use the angle given, use the angle that will sum up with the angle given to give you 180 if the forces are not perpendicular. Now I'll give you one classwork. Do this for me very fast. Send your answer to me on the comment section. Do this fast. Two forces, 3 Newton and 4 Newton, act at 120 degrees to each other. Determine their resultant. I told you, don't use the angle that is given you. Make sure you look for the angle that you add to this one to give you 180. That's the angle you have to use. So yeah, do that for me very fast. You have 2 minutes to do that. Someone is asking, how did I get 120 degrees? Now, someone is asking, how did I get 120 degrees from the first question? The first question, they told us that the angle between them is 60 degrees. Now, wetin I go add join this 60, wey go give me 180, no be 120. Yes, that's how I got 120 degrees. The angle you will add to the angle that they gave you to make it 180, angle you have to use. They give you 120. Which angle I go add join am to make am 180? Now that angle you go use to solve the question. Wow, I'm seeing some people's answer. Please do that fast for us. Someone got 6.08, someone got 3. Someone got okay, someone is asking if the angle that is given is more than 180. Let's take a sketch of this diagram. If it is like this, for instance, if the angle is more than 180, let's say the angle is 230 degrees. If this is F1 and this is F2, watch, just watch this. How do I produce a parallelogram from here? Shebi this line must be parallel to this line I want to draw. So it will be like this, just watch. And then you have something like this. Now, which angle is this? If they give you 230, don't forget that the angle is now forming is a reflex angle. And I have succeeded in drawing my parallelogram. So the angle that you add to 230 to give you 360, that's this full angle. I think it will be 360 minus 230. That will give you 031, 130. So you have 130 here. Can I solve with 130? No, you cannot. What you will do, you must get your resultant, which is this one. Okay, so if they give you an angle like 230 degrees and the angle is bigger than 180, remove that angle from 360 first to get the reflex of that angle, which will give us 130. Do you now use that 130? No. The angle you will add to that 130 to make it 180 is the angle that you use. That means the angle that we are going to use will be 50 degrees. If it is clear, please send a comment to the comment section. Let me know you understand it. If not, you can say no, you don't understand. Wow, that's good. Wow, like that. Okay, let us, some persons got 4, some persons, please, I think Angel Tochi, I don't understand what you are saying. You said 0.5 watts. Please, can you please? Okay, I think we have to do the correction so we can move further, please. Let's quickly do the correction. You don't have to bother yourself to draw any diagram. I only just drew a diagram because I wanted to make it clearer for you. You don't have to worry yourself. I told you, which angle will I add to 120 now? Make the angle for turn 180. No be 60. Yes. Shebi na 60. Yes. If I put 60 join 120, shebi go give us 180. Yes. Will I use 120 to solve the question? No. Shebi na 60 I go use. Yes. So if I'm using 60, use cosine rule and use 60. Very easy. Cosine rule say arrow square get 4. Now we wan put angle cos I go put 120 for here. No, I go put the angle when I go add join 1 to do give me 180. That angle na wetin 60. You dey see am na? Yes. 3 square na 9. 4 square na 16 minus 2 times 3 6. 6 times 4 24 times cos 60. Wetin be cos 60? 0.5. You dey see am now? 9 plus this one na 25. 24 times 0.5 will give us 12. Wow, that's very cheap. 25 minus 12 na wetin na 13. Abi na good. Arrow will give us square root of 13. What would that give us? .61. 3.61 what? Newton. Now the answer be that, class. Wow, how many persons got it? So if you did not get it, please do your correction. Now let's go the last case. There's remaining just one case for scalars and vector. The last case, you can screenshot this on your system. Just screenshot it. Okay. The last case of scalars and vector is resolution of more than 2 vectors. If I get more than 2 vectors and I want to resolve them, how do I do it? Resolution of more than 2 vectors. How do I do it? Very easy. The steps are given below. Step 1. Sum up the horizontal component. That is step 1. Step 2. Sum up the vertical component. Step 3. Use Pythagoras theorem. That's the 3 step. Or you write am down, make I give una one question. Make una see how to apply am. Sum up the horizontal component. Remember that horizontal component has to do with cos theta. Now, step 2, sum up the vertical component. It has to do with sin theta. Then Pythagoras theorem, you know the story now. Arrow square is fs squared plus fy squared. And we together, please do that now. Now, let me clean the board and we'll take a question. (30°), 10 Newton. 3 Newton. There is a force here. 6 Newton. There is a force here. 3 root 3 Newton. The angle here is 60°. Wow. Calculate the resultant force. In the figure, calculate the resultant force. Very easy. If you are giving this question in your JAM exam, just follow these simple steps I'm about to give you now. Step 1, what did I say? Sum up the horizontal component. That's what I told you. Horizontal component, let's start with that. Horizontal component. Horizontal component. Horizontal component. See am, na im be this. We go sum am together. Remember, say horizontal component na cos theta we dey use. And because we are using cos theta, let us take it one after the other. More number the forces now. This is force number 1, force number 2, force number 3, and force number 4. You fit get horizontal component, and wetin you go use na wetin na cos theta. Yes or yes? Yes. Now, cos theta, we go start with this guy. Now, remember, say, since we dey talk about horizontal component, and you know, say, horizontal component then, na the x-axis e dey. You dey get am? So, this guy na s-axis. And for s-axis, remember, say, here na negative. Sorry, here is positive, and here is wetin na negative. This is positive s. This is negative s. So any force wey dey here go be positive, but the one wey come go dey here go be negative. For horizontal component, as you dey see am now. Okay, now if I wan go this question, how I go take go am? Very easy. Shebi this one na the first force, 3 Newton. Now as this first force be 3 Newton like this, which angle this first force now dey make with the horizontal line? Which angle e dey make? Shebi this guy dey the horizontal line. Any angle dey here? No, e no make any angle. So the angle of this guy na 0 degree. And if na 0, e mean say here go be 3 cos 0. H2O, why you put 0? Because the force here is in the horizontal line. And if it's in the horizontal line, the angle is 0. Now, what do we do to the second force? We add them. Like I told you, add all the horizontal together. Now, this number 2 now waiting na 10. Which force, which angle this guy make? No be 30 degree there here. It go be 10 cos 30. You understand now? Yes. Oya, come here. This guy now waiting. 3 root 3. Which angle this guy make with the horizontal? No be 90 degree like this. Yes. See, from here to here 90. This one 30, but this guy 0. So you have cos waiting now 90. So we don't do 3. This last guy now come go to the negative side. See, I'm here now negative. So he go be waiting now minus 6 waiting cos. Which angle they here? 60 degree. But take note, make sure that all your angles are to the horizontal. No angle should be to the vertical. If they give you any angle, I beg, no use them. Use the one way there. If they give you here as 30 degree, no use them to fail. Use the angle way there. You go say 90 minus this 30 will give you 60. You can't get the angle way there. Now the angle way there to the horizontal line, now with the, you don't be vertical, so that you will not get confused. Now you have 3 cos 0 is equals to waiting now 1. Plus 10 bracket, wetin be cos 30 root 3 over 2. You dey get am? Plus 3 root 3, wetin be cos 90 0 minus 6 bracket, wetin be cos 60 0 point wetin na 5. Wow. So wetin I get now? 3 plus. Can these two optimize 10? Yes, it will give us 5. So you have 5 root 3. Shebi this one go turn 0 because 0 times anything is 0. Then minus 6 times 0.5 will give us minus 3. So if 3 minus this 3, shebi na 0 you get. Last, for the horizontal component, we call get weighting 5 root 3 weighting Newton. You dey get am? Yes. Now, if for instance, the same way you find the resultant force along the x-axis, this would have been our final answer. But the same way we get the resultant of everything, we were told to find the resultant. This resultant is not to the vertical, Neither is it to the resultant. They are referring to the total resultant. So for total resultant, after you don't get your resultant component, you must get your vertical component. Oh yeah, maybe we get vertical component now. Remember, say I tell you now, say vertical component, you go use wetin na? You go use sine theta. Yes, you must use sine theta. Oh yeah, most of that they run this thing sharp sharp. This guy go be wetin? He go be. Remember, say for vertical component, here na plus, up, plus, down, minus. So for vertical component, this guy will be 3 sine 0. I tell you, say this guy, the angle wey this guy make with the result na 0. Enter here, plus 10 sine. Which angle dey here? 30. Enter here, plus 3 root 3 sine what? Sine 90. Enter this guy. Remember, say if you dey up positive, but if you come down negative, so there go be negative. Minus 6 sine wetin na 60. Oya, mo do am sharp sharp. Wetin be this one now go give us 3 bracket 0. I hope you are seeing it clearly. This will give us 3, this one, bracket sine 0 na 0. Okay? Then plus 10 bracket sine 30 na 0.5. Plus 3 root 3 sine 90. 3 root 3 sine 90 na 1. So you have 1. Then this last one will be what? Minus 6 sine 60 na wetin na? Root 3 over 2. So what do we have? Let's create a space here. What do we have? We have minus 6 bracket root 3 over 2. That's what we have. Okay? So how do we do it now? Let us create a space here and solve it finish. Now, for this one, we have 0. For this guy, 10 times 0.5, you get wetin na 5. Root 3 root 3 times 1 plus root 3 root 3. 3 root 3. 2 optimize 6 will give us 3 times this minus 3 root 3. So minus 3 root 3 will give us 0. So what we left? 5 Newton. So this one, now wetin we get for the vertical. Why this one, now wetin we get for the horizontal. I tell una say, sum up the horizontal, sum up the vertical, then use Pythagoras theorem. Use Pythagoras theorem. If you are using Pythagoras theorem, what do you do? Very easy. Now, according to your Pythagoras theorem, remember say arrow square is equal to the square of the other side. So by Pythagoras theorem, arrow square will give us the first one. Should be the first one now, 5 root 3. So you have 5 root 3 what? Root 3 square. Okay. Then you have 5 root 3 square plus the next one is 5 square. So what would that give us? Square this 5, you go get 25. Square root 3, you go get only 3. Square this 5, you go get 25. 25 times 3 na 75. Plus wetin? 25. So therefore, if you add them, you go get 100. Therefore, arrow will give us the square root of 100. Therefore, the answer is 10 Newton. Now the answer be that. So you go sum up the horizontal, you go sum up the vertical, you can't apply Pythagoras theorem. Let me give you a question to solve. And I'll give you just 2 minutes. Though I'm not going to make it as complicated as this. Do this for me, please. Find the resultant. Do that fast. Just 2 minutes, please. Now, should I solve this question or I should give you 2 more minutes? If you want me to give you 2 more minutes to solve this question, just make a comment in the comment section. Let me see it. Or if you want me to solve it for you to understand it better, I can do. Giving you just 1 minute to make a comment on the comment section if you want me to solve it or you want me to leave it. Let's see. Now let us solve this question now. Now I'm going to cut it short. You know, the first time I was solving, I was actually doing it so that you understand it better. But I think I can cut it shorter than what I did before. You can even use your calculator to solve it. But however, let us just do it again. The step one I told you about is sum up the horizontal using cos theta. Don't forget. So it will be 8 cos 0. 8 cos 0 plus 5 cos 60. This one plus 4 cos 90. If you come down, this side negative, so it will be minus 5 what? Cos 30. So let's quickly use our calculator. 8 cos 0. Cos 0 is 1, so you have 8 here. Plus cos 60 is 0.5 times 5, 2.5. Cos 90 is 0, so here we turn 0. Cos 30 is root 3 over 2, so you have minus 5 bracket. Root 3 over 2 is 0.866. So you have this plus this, you have 10.5 minus, let's multiply 5 times 0.866. 4.33. So you have 4.33. Okay? So what do? 10.5 minus 4.33. 6.17. 17 Newton. Okay? This is called your horizontal component. Now, step 2, sum up the vertical component. Sum up the vertical component. If you want to sum, use sin theta. So this will give us 8 sine 0. This will give us the same thing, 5 sine 60. This will give us 4 sine 90. You just have to change your cos with sine. This will give us minus 5 sine 30. So times 0 is 0. So that one is out. What you have here is 5 brackets root 0 over 2, which is 0.866 plus 4 bracket 1 minus 5 bracket 0.5. So let's have a calculator to do that. 2.5. 5 times 0.866 plus 4 minus 2.5. 5 times 0.866 will give 4.33 plus 4 minus 5 times 0.5 is 2.5. 2.5. 5.83. So what you have there is 5.83. So you can now use Pythagoras theorem. R square equals to this what? 6.17 square. But the square of the second 5.83 square. So R will give us the square root of whatever you have here. So let's do it. You have 6.17 square. That will give us 38.1. Okay, let's take it gently. 38.1 plus 5.83 square. 5.83 square. That will give us 33.99. Okay, add to this. That will be 2.1. I will give us brush of 2.1. So you have square root of 72.1. That will give you 8.5. So the answer is 8.5 Newton. So you can mark yourself. I have one more question for us, and you take it as your homework before we come to the end of this video lesson. This time, the question here is cheap. You have a diagram this way. Just 3 forces. This one, 16 Newton. This one, 4 Newton. This one, 2 Newton. The angle here is 30 degrees. The angle here is 30 degrees. Okay? Now, find the resultant. Find the resultant in the x direction. Find the resultant. That means just resolve to the resultant using cos theta only. Don't do sin theta, cos theta, Pythagoras theorem. No, in the x direction. That means just resolve it to cos theta only. Do this to cos theta. Whatever you have as your answer is the resultant. Don't do to the vertical. Don't use sine. Just do only for cos. Option A. Option A. 11.46. 11.46 Newton. Or 13.46 Newton. Option C. 19.92 Newton. 19.92 Newton. D. 14.02 Newton. Please, by the time you are done with the answer to this question, send it to me on the comment section for correction. Thank you very much. We are going to continue from here tomorrow. Okay? Thank you. I'll see you in my next video. God bless all of you that have been with us from the beginning of today's video lesson to the end. And I want to assure you that you are coming out with a testimony. You are going to blast your jam in flying colors. If you believe, type amen in the comment section. I'll see you in my next video. Don't forget to subscribe. And also please help us to like this video and share to your friends. Thank you.